Hi everyone. Today we are going to continue with our third module, Natural Disasters. We're going to begin reading our new text, Eruption, Volcanoes and the Science of Saving Lives by Elizabeth Rush, photographs by Tom Ullman. So this text is a narrative nonfiction. Narrative nonfiction gives factual information by telling a true story. So when we listen, we're going to hear the text presented in sequential or chronological order. So this helps us understand how the events happened and how they're connected. Narrative nonfiction also includes visuals such as photographs and captions, which help to explain what's going on in the photos and add detail to the text. Texts written about events related to science or social studies may also include words that are specific on the topic, which are called content-specific words. So as we look at the text, you're going to notice that it looks like there are torn paper visuals and large pull-out quotes. And these are going to sort of be eye-catching and help us understand what was going on in the moment. And it shows us that the author is trying to write this as a story as well as factual information. Our learning target for today is I can make and confirm predictions using text features and structures. So as we're making predictions, which is a best guess about what is going to happen in the story or a part of a story. So before we start reading, I'm going to have you look at the cover and read the title, and then flip through to see some of the photographs and illustrations that are within the text. And then we're going to predict what the text will be about. As you're reading, you're going to stop and think about what you read. What do you think will happen next? And after you're done reading a section or the whole text, you're going to adjust your prediction. Was I right? All right, so I am on page 183 in my text. So as I look at this page, I start to notice what the author includes, and I see these little squiggly lines, and they make me think of some kind of monitor. So it kind of makes me think of like a heart monitor that you sometimes see in like a TV show about a hospital. So it reminds me of something that they're trying to take a measurement of. So I'm guessing that there's going to be some kind of information that people are collecting. So I'm on paragraph 1, and I'm going to try and see if I can figure out why they're including those little squiggly lines on this page. When the Colombian volcano Nevado del Ruiz erupted in 1985, United States Geological Survey, USGS scientist Andy Lockhart was horrified by the tragedy. A year later, he became one of the earliest members of a volcano crisis team called the Volcano Disaster Assistance Program, or VDAP. The VDAP's mission is to bring equipment and knowledge to areas threatened by volcanoes in order to predict eruptions and prevent catastrophes. 6 years after the program started, Chris Newhall, another VDAP scientist, got a call about steam shooting from Mount Pinatubo, a mountain in the Philippines. Until this happened, most people thought Mount Pinatubo was a huge jungle-covered mountain, not a volcano. Chris knew it was serious, and he and the team had to do something. He and fellow VDAP scientists, Andy Lockhart and Rick Hoblet, set out to predict Mount Pinatubo's next move. They worked from the Clark Air Base, very close to the volcano. So then I see these lines, and I'm thinking that they might be trying to monitor something to do with the volcano. On May 28th, Chris got a new gas reading from Mount Pinatubo. Sulfur dioxide had jumped tenfold to 5,000 tons a day. The volcano was definitely ramping up. A few days later, instruments recorded two unusual earthquakes. A shallow, continuous rhythmic shaking known as a low-frequency earthquake meant magma was moving toward the surface and releasing more gas. Then, the seismographs recorded the first earthquake directly under the vent. Over the next few weeks, the volcano spat steam higher and higher into the sky. The plume changed color from white to gray. Then the volcano began shooting rock and ash. But the geologists tested the ash and found no sign of fresh lava. The steam explosions were just tossing up old material. Would the volcano erupt, or would it just spit steam until it slipped back into dormancy? And if I look at the word dormancy, I see a little 1 after it. That is called a footnote. So we're going to look at the bottom of the page, and you'll see another little 1, and it tells us that dormancy is the period during which a volcano is temporarily inactive. Now I'm on paragraph 5. Then the sulfur dioxide plummeted from 5,000 tons to 1,300 to 260 a day. That could mean that the volcano was settling down. Or it could mean that the volcano's vent was clogged with pressure building. Andy and the other scientists watched the seismograph around the clock. They saw bigger quakes, longer quakes, and a harmonic tremor, a constant humming earthquake that often means magma is rising and boiling away groundwater. Ooh, I see a little 2, so I'm going to look at the bottom of the page. 2 is groundwater, water found underground in the cracks in sand, soil, and rocks. Now I'm on paragraph 8. The Americans and Filipinos each had their own alert level systems. The VDAP scientists debated, was it time to raise the alert level to 3? High and increasing unrest, eruption possible in 2 weeks? Ray, the head of the Filipino geologists, would need time to spread any warning to the people scattered in villages all around Pinatubo. He raised his alert level to 3, eruption possible in 2 weeks. About 10,000 members of the Eta tribes were moved to evacuation camps. So if I look at number 3, it says Eta tribes, tribes of people native to the island of Luzon in the Philippines. Paragraph 10. The quakes accelerated. Magma moving all along the conduit was shaking the ground deep in the earth and quite near the surface. More and more steam and ash poured from cracks in the volcano, called fumaroles. The volcanologists estimated the size of the magma chamber, the reservoir of melted rock and gas under the volcano, and the potential size of the eruption. The eruption could be 10 times larger than the 1980 eruption of Mount St. Helens, which was bigger than any living geologist had ever seen. Military officials listened intently to the geologists' briefings. At the end of one, Major General William Studer asked, "What would you do?" The scientists answered, "Move the dependents off the base." The officers relocated pregnant women and the elderly. The Air Force newspaper and TV station began broadcasting details of an evacuation plan. What to bring and where to go. So we're going to pause here for today, and I want you to really think about, based on what the scientists have seen so far, what do you think is going to happen next? So you're going to use some evidence from the text to make a prediction, because making a prediction, we're going to make a best guess based on what we know.